All right, so these are the notes for Monday's lesson. So let's go ahead and get started. Scholars will be able to use midpoints and segment bisectors to find the lengths of segments in complex diagrams. All right, so the entire point of today's lesson is about midpoints and segment bisectors, okay? So a midpoint, it's the point that divides one segment into two congruent and equal segments, okay? So for example here, if B is the midpoint of AC, then what's the first conclusion? Well, you know that this line is congruent to this line. So the first conclusion, that's the obvious one, is that line AB is going to be congruent to line BC. Okay, that's very straightforward. But what else can we derive from this information? If you think about it, this is the same thing as this. So if I only had AB and I had 2 of AB, right? That's actually going to be the same thing as the entire length of AC, line AC, okay? Another way of expressing this would be using just BC. If you only had BC, you would know that twice the length of BC, right, would be congruent to all of AC. And that's pretty much it. It's very straightforward, okay? So that's how the idea of a midpoint is useful. Now, segment bisector, a line, comma, segment or ray that intersects a line at its midpoint, okay? What does a segment bisector do? It intersects a segment, a specific line segment, at its midpoint, okay? Now, to bisect a segment means to divide it into two congruent segments, okay? And that makes sense, right? So if you are a bisector, you're hitting a line at its midpoint, therefore you create two congruent segments. So let's take a look at this. If AB, and the language is very important, pay careful attention. If AB bisects CD at point E, then, well, here's the picture, okay? Guess between C and D, or A and B, which one is the segment bisector? In this case, AB is bisecting C and D. So AB is the segment bisector, and then CD is being bisected. It's being split in half, okay? If this is the case, because CD is being split in half and E is basically the midpoint right here, we can make a couple of conclusions, right? We know that CE and ED are both going to be congruent. So CE is going to be congruent to ED, okay? That's the first piece. And the other thing is, because we're using this keyword bisector, E is going to be the midpoint, right? Point E is the midpoint, okay? All right, so far so good. Now let's take a look at one very quick example so that you guys get the language down correctly, okay? It says, segment FG is bisected by AB at point M. Draw a diagram to represent this scenario, including congruence marks. Which of the following statements is true? You can't figure out this without actually a diagram, so make sure you do. It says segment FG is bisected by AB. So that means you start with a segment and you label it FG, right? And then it gets bisected by line AB. So it doesn't matter which direction, left, right, etc. As long as you have something where AB is doing the bisecting, right? And it's going to probably create a midpoint at point M, okay? So now, what's true? Well, because FG is the one that's being bisected, only these two sides are going to be congruent, right? So we know that FM has to be congruent to MG. That's it. So the final answer to this question would be B.